So in this video, we're going to look at finding the equation of the tangent to a curve at a particular point. Okay, so we've got the curve y equals x squared, and you can see the tangent here is drawn in yellow, and it's touching the curve at exactly one point. Okay, so you can see the point there in red, the point 1, 1. That's the only time, the only point that these two lines or these two curves intersect. Yeah, no other point do they touch each other. So we first of all, to find the equation of a tangent, we have to first find the gradient of the tangent. Okay, so our first step is to differentiate the curve. So y prime, so the derivative, is going to equal 2x. Okay, so all I've done there is differentiated that curve. So y equals x squared becomes y prime, or derivative, equals 2x. Now, to find the gradient at the point 1, 1, all I have to do is substitute the x coordinate into that derivative, and that'll give me the gradient at that point. Okay, so the x coordinate that I'm looking at is 1. So it's going to look something like this. So when x equals 1, the derivative is going to equal 2. Okay, so all I've done is put x equals 1 into that derivative formula, and I end up with a derivative of 2. Okay, so that tells me that the slope or the gradient of this line, of this tangent line, is 2. So now that I've got that, I can use this formula, which is going to help me find the equation of the actual tangent, of the actual line. So y minus y1 equals m, and then x minus x1. Okay, and I'll just take you through this formula. You may have seen this one before, but it's got we've got a y and an x, and then we've got a y1 and an x1, and then an m. Okay, so this is the formula that we use to find the equation of a line when we have an m. Okay, when an m is a gradient. Okay, and we've got that. That's our 2 there. And we also have a y1 and an x1, okay? And that's just the x and the y coordinates for our point that we're looking at, which is 1 and 1, okay? So now what we can do is just substitute those different values into the formula, and that's going to give us the equation of the tangent that we're after, okay? So let's have a look. It's going to be y minus, I'll just write out the formula actually. So y minus y1 equals m, and then x minus x1. Okay, so that's the formula. Now what we can do is substitute the values in. So it's going to be y minus, and we're looking at that. So it's y minus 1, and then equals, and here's where we put our derivative in. Okay, so the derivative is 2, so we put that in there. And it's going to be x minus, and the other value is 1. Okay, so x minus 1 there. Okay, so now I can just expand these brackets. So y minus 1 equals, and it's going to be 2x minus 2. And now what I can do is just add 1 to both sides, okay, to isolate the y by itself over on the left of the equation. And it's going to be 2x and then minus 1. Okay, so I've just added 1 to both sides. And that's it. Okay, so that's the equation of the tangent at the point 1, 1. Okay, so y equals 2x minus 1. So here's another example, and this one is a little bit harder, okay? But it's just going to be exactly the same process that I just went through. So feel free to pause the video now and have a go at it yourself, but otherwise you can just watch me go through it. So the curve is y equals x squared plus 12x plus 20, and you can see it there on the graph. And we've got the tangent, and then the point we're interested in is minus 8 minus 12, okay? So let's have a look. First of all, we have to find the gradient, okay? So we're going to differentiate the curve, which is going to be, sorry, I just made a mistake. So 2x plus 12, okay? Sorry, that's a bit messy. Yeah, the derivative is 2x plus 12, okay? So now we're looking at the point minus 8 minus 12. So I'm going to try and find the gradient of the tangent at the point minus 8, or at the x coordinate minus 8. So when x equals minus 8, the derivative is going to equal minus 16 plus 12, okay? And that's going to be minus 4, right? So that's minus 4. Our m value in our formula, which we're just about to use, is minus 4, okay? So now what we can do is substitute our values into that equation, because we've got everything we need. We've got an m value of minus 4, and then we've got an x1 of minus 8, and then an a y1 of minus 12. Okay, so we can put all of that in, and that'll give us the equation of the tangent. All right, so let's go y minus, and then we do y1. So it's actually going to be plus 12, okay, because I've got y minus minus 12, so it becomes plus 12 equals, and then we've got our m, okay, which is minus 4. That's just the derivative we worked out earlier. Minus 4, and then we've got x, and it's going to be x minus x1, but x1 is minus 8, so it's going to be plus 8. And that's it. Okay. So now we can just expand these brackets. So get rid of the brackets, minus 4x, and then minus 32. And now I can subtract 12 from both sides to get the y by itself over on the left of the equation. So minus 4x and then minus 44. So 32, minus 32 minus 12 is minus 44. And that's it. Okay. So there's the equation of the tangent at the point minus 8, minus 12.